Hello student, I am Nirmala Morade, Department of Mathematics from S.V.K.T College, Devali Camp, Nasik. In today's lecture, we are going to study the concept non-existence of limit of function of two variable from course MT 231 Calculus of several variable from unit 1 limit and continuity. Before studying this concept, let us recall the previous lecture. In previous lecture, we studied the definition of limit of function of two variables. So for that, suppose we consider a function f of xy defined on the domain D, which is subset of R2. Then a real number L is said to be limit of the function f of xy as xy tends to AB, point AB, where AB is the point in D. If for every epsilon greater than 0, there exists a real number delta greater than 0, such that for all xy belongs to D, that is domain of the function, mod of f of xy minus L is less than epsilon when 0 is strictly less than mod of root of x minus a bracket square plus y minus b bracket square is less than delta. So in last lecture also we studied the algebraic properties of limit of functions and the related examples. So in today's lecture we are going to study what is the non-existence of limit by using the two-part test. Also we are going to study the examples, how to show that the limit of the given function does not exist. After watching this video, students are able to understand the concept of limit of function of two variable does not exist, also able to find the suitable path for non-existence of limit, and also students are able to solve the related examples. So these are the learning objective of today's lecture. Now already we have to study this concept in a last class, that is in FY BSc, that is non-existence of limit for function of single variable. So we know that the real line geometrically represent a real axis, and if we consider a point on real axis, there are two paths only available to approach to that point. That is, we have only two choices to approaching the point A, either from right side or from left side. So suppose we approaches to that point from right side, then the corresponding limit of the function f of x is said to be right hand limit. And it is denoted by a limit of fx as x tends to a plus, and if we approach that point from the left, then the corresponding limit is called the left hand limit. And as we know that if the right hand limit is same as left hand limit, this common value is called the limit of the function fx as x tends to a. But if right hand limit is not same as the left hand limit, then in that case we say that the limit of the given function does not exist. So now we will study the similar concept for the function of two variables. So in case of single variable, there are only two possible paths are available to approaching some point or to approaching a real number. But that not happens in case of function of two variables or in case of R2 plane or XY plane. So suppose see in the diagram, if we consider a point AB, then there are infinitely many paths are possible to approaching that point AB. So suppose we want to show that limit doesn't exist or non-existence of limit in case of function of two variable. So in that case we have to find two paths. We have to find the two paths such that along that two paths, if limit doesn't exist, then we say that along these two paths, the limit of the two different functions or limit of the function is different, then we say that limit doesn't exist. That is, suppose we consider the first path C1 and the limit of the function f of xy along that path is L1. Consider the another path, suppose there is another path C2 and limit of the function f of xy along C2 is L2, and if both L1 and L2 are different values, then in that case we say that the limit of the function f of xy as xy approaches to AB does not exist. That is, in case of function of two variable, suppose we want to show that limit doesn't exist, then in this case we want to find the two paths C1, say C1 and C2, such that as xy approaches to AB along these two paths and the limit of the given function along these two paths have different values, then we say that limit doesn't exist. But now here remember one thing, if suppose limit along C1 is L1, limit along C2 is L2 and both have same value, then we can't say that limit exists in that case. So this test is applicable only if limit along two different paths have different values, then we say that limit of the function f of xy as xy approaches to AB does not exist. Now let us consider some examples. The first example is, show that the limit of x square minus y square upon x square plus y square as xy approaches to 0, 0 does not exist. So now here our point is 0, 0. Function is x square minus y square upon x square plus y square. Now since we want to show that limit doesn't exist, that is, in this case we want to find the two paths approaching to 0, 0 such that along these two paths the function have different limits, and then we say that limit of the function does not exist. So since the point is 0, 0 here and the simplest path approaching to 0, 0 are x-axis and y-axis, so let us first find the limit of the given function along x-axis as well as the y-axis. So this is our function f of xy is x square minus y square upon x square plus y square. So as xy approaches to 0, 0 along x-axis, that is y equals to 0 line, we know that the equation of x-axis is y equal to 0. So to find the limit of the function along x-axis, first we put y equals to 0 in a functional value. So replace y equals to 0 in f of xy. So function value becomes f of x comma replace y by 0 is same as x square minus 0 square upon x square plus 0 square. So if we simplify it, we get 1 here. Obviously here x not equals to 0 because numerator is x square and denominator is x square. We cancel this if and only if x is not equals to 0. So the functional value along x-axis is 1 except origin. Okay. Since here the functional value is constant, which is 1, so the limit is also 1 here. So f of xy is approaches to 1 as xy approaches to 0, 0 along x-axis. Now do the same procedure to calculate the limit of the function along y-axis. So now we consider as xy approaches to 0, 0 along y-axis, equation of y-axis is x equal to 0. So first we have to calculate the functional value by putting x equals to 0 in the function f of xy. So the function becomes f of x is replaced by 0, so 0 comma y is same as 0 square minus y square upon 0 square plus y square, which is same as minus y square upon y square. So now here y square gets cancelled if y not equals to 0. So the functional value is minus 1. for all y is not equals to 0. Again this is a constant value. So again this is a constant, so limit is also the constant, or we say that here limit of f of xy is -1 as xy approaches to 0, 0. So f of xy tends to -1 as a xy approaches to 0, 0 along y-axis. So if you remember here, limit of the given function along x-axis is +1 and along y-axis it is -1. So now here limit of the given function along different path have different values, and so we say that the limit of the given function does not exist. So this is the diagram I just see here. As a functional value along x-axis is 1, along y-axis it is -1. So here we are able to find the two paths, so along which the function has different values. So limit has also different values, and so limit doesn't exist. Okay. Now let us consider the another example. So the another example is, show that the limit of the function xy upon x square plus y square as xy tends to 0, 0 does not exist. So now here again our point is origin. So simplest path approaching to origin are x-axis and y-axis. So first we have to find here limit of the given function along x-axis. So now for that, first we have to put y equals to 0 in the functional value. So the function becomes f of x comma 0 is same as x into 0 upon x square plus 0 square, which is equals to 0 for all x not equals to 0, which is again a constant. So f of xy approaches to 0 as xy approaches to 0, 0 along x-axis. That is the limit of the given function is 0 along x-axis. So similarly you can find the limit of the given function along y-axis. Okay, it is easy to find. So again we get here limit of the given function along y-axis is 0. So now see here, in this example limit along x-axis is also 0, limit along y-axis is also 0, but we can't say that limit doesn't exist. Okay, we can't say that limit of the given function doesn't exist. So suppose our question is to find to show that limit doesn't exist. That is, in this case we must find another path such that limit of the given function along that path is different from 0. So now here I consider the another path which is a straight line y equals to x. So as xy approaches to 0, 0 along the line y equals to x. So now first we have to find the functional value along this line. That can be found by using putting y equals to x. So now first step is put y equals to x here. So functional value becomes f of x comma x equals to x into x square plus x square is equals to x square upon 2x square equals to half for all x not equals to 0. So now it is very easy to find the functional value. Just replace in the original function y by x. Again this functional value is half here, so which is a constant. So we say that f of xy tends to half as xy approaches to 0, 0 along the line y equals to x. So now here along two different paths, along the x-axis or y-axis the limit is 0, and along the line y equals to x the limit is half. Since the limit is half and 0 both are different values, so along different paths we obtain the different limits, and so in this case we say that limit does not exist. So again see the diagram here. If you approaches origin along x-axis, functional value is 0, so limit is 0. Along y-axis, again the functional value is 0, that is limit is 0. And along the line y equals to x, the functional value is half, which is constant, so that's why limit is half. And so here we obtain the two paths along which function has, or the limit has, different values. So we say that here limit doesn't exist. So now this is a third example. Show that the limit of x into y square upon x square plus y square as xy tends to 0, 0 does not exist. So now here function is f of xy equals to x into y square upon x square plus y square. Now as usual, first we have to consider a simplest path, either x-axis or y-axis. I consider here x-axis. Find the limit of the function along x-axis. So for that we put y equals to 0 in the function, and so this function becomes 0 here. So which is again a constant, and that's why limit of the given function is 0 as xy tends to 0, 0 along x-axis. Similarly, you can find the limit along y-axis. Suppose I want to find the limit along the y-axis, that is we put y equals to 0 here, and if you put y equals to 0, then what happen here? X into 0 upon x square plus 0 square, again we get the 0. So now here we want to find the another path. So now then how to find the another path for this function, so that we will get the different limit or the limit other than 0. So if you observe the first or the second example, if you remember the first example, the function is x square minus y square upon x square plus y square. So if you observe the degree of each variable in numerator and denominator, so that are equal, x square minus y square upon x square plus y square. So degree of x is same as the degree of y. In second case, the function is xy upon x square plus y square. So in numerator degree of x is 1 and degree of y is also 1, and in denominator is x square plus y square, degree of x is same as degree of y. So in that case we consider the path y equals to x. So now here observe the function, numerator is x into y square. So here degree of x is 1, degree of y is 2, and denominator is x square plus y raised to 4. Degree of x is 2 and y is 4 here. That is here in this case, in each case, in numerator as well as denominator, degree of y is 2 times the degree of x. Degree of y is 2 times the degree of x. So directly we can consider the path y equals to mx, that is a family of straight line passing through origin. Or simply, since we have to already find the limit along x-axis, we need the another path, and so here degree of y is 2 times degree of x. So instead of finding the limit at x equals to y or at x equals to my, find the degree. Observe the degree carefully. Degree of y is 2 times the degree of x. So consider the path x equals to y square. X equals to y square, or you can directly consider the path x equals to my square, that is family of all parabolas passing through the origin. So now here, to find the limit of the given function along the parabola x equals to y square, we put x equals to y square in the function value. So it becomes f of y square comma y is same as y square into y square upon y raised to 4 plus y raised to 4 is same as y raised to 4 upon 2 times y raised to 4. So y raised to 4 gets cancelled here if y not equals to 0. So this functional value is half if y not equals to 0, which is again a constant. So f of xy equals to half as a xy tends to f of xy tends to half as xy tends to 0 0 along the parabola. So for this function, limit along the x-axis is 0 and limit along the parabola x equals to y square is a half. And since we obtain here two paths such that limit of the given function along these two given paths are different, so we say that limit of the function does not exist. Now this is one example. Now observe each and every example. Each and every example is different from each other. In first example, we find the limit along x-axis and y-axis. So we will get the possible paths. So in second case, we consider the path as a straight line. In third case, we consider the path as a parabola, different another path as a parabola. So always observe the function and then decide which path is suitable for non-existence of limit. So now here next problem is different from the other three or first three problems. Show that limit of xy minus x upon x minus 1 bracket square plus y square as xy tends to 1 0 does not exist. Now in previous three problems our given point is or xy is approaches to 0 0, but in this case xy is approaches to 1 0, so we can't consider the path x-axis as well as the y-axis because these both the paths are not passing through the or y-axis is not passing through the point 1 0. Okay, we can consider here x-axis also. So better way is suppose I want to find the limit of the function along at some point, or we want to show that limit doesn't exist. Try for the straight line which is passing through that point. So now here this is our function f of xy equals to xy minus y upon x minus 1 bracket square plus y square. So I consider here a straight line. X minus 1 is same as m into y. So m is constant here. So for different values of m, we will get the different straight lines that are passing through the point 1 0. So now to find the limit of the given function along this path, so we have to substitute either x equals to my plus 1 or put x minus 1 equals to my here. So now here first we replace x equals to my plus 1 in the given function. So given function becomes f of 1 plus my comma y is same as m replace x by my plus 1. So 1 plus my into y minus y upon my bracket square plus y square. Just simplify it. After simplifying it, we will get m upon m square plus 1 for all y not equals to 0. So now here this is again a constant value. Because if we put the different values of m, we will get the different straight lines passing through the point 1 0, and for different values of m, we will get the different limits here because the limit depends on m here. So here function value is m upon m square plus 1, which is a constant. So limit is again same value m upon m square plus 1, which is constant, which this constant or this limit depends on m. For different values of m, we will get the different straight lines. That's why we will get the different limits of the function, and that's why we say that limit of the given function does not exist. Okay, all four problems are different, so observe all the four problems carefully. At least observe all the functions carefully. Okay, these are some assignment for you. Solve these assignments. So let us summarize our today's lecture. So in today's lecture, we have studied non-existence of limit. So if limit exists, suppose limit of the given function f of xy as xy tends to a b is equals to L. If for every epsilon greater than 0, there exists delta which is also greater than 0, such that if xy belongs to D, where D is the domain of the function, and 0 is less than root of x minus a bracket square plus y minus b bracket square is less than epsilon, then mod of f of xy minus L is less than epsilon. Then in this case we say that limit exists and it is equals to L. But suppose we want to show that limit does not exist, so in that case find two paths as xy approaches to that point, say AB, such that limit of the given function along these two different paths has different values. So in that case we say that limit does not exist. So these are some additional references for you. So next lecture we will study continuity of function of two variables, its definition and related some results as well as the problems of continuity of function of two variables. Thank you.